So this is LeetCode problem 155 MinStack. So you are given a class called MinStack, and you have to implement all of these methods. So right here is your constructor. So this is what's going to happen every single time a MinStack is initialized. Then you have to implement push, and that will push whatever is passed through here onto the stack. Whatever int this is, will put it onto the stack. Pop will remove whatever is at the top of the stack. If you call top, it's going to return an int that will give you the top element of the stack without removing it. And if you call getMin, this will give you the minimum element in the stack. So in this example, MinStack is called, which means there's a new MinStack object created. Push is called, push is called, push is called. So it's push -2, push 0, push -3, push those all into the stack. GetMin is called. You're supposed to return the minimum amount that is on that stack. Pop is going to remove whatever is on the top of the stack. Top is going to return whatever is sitting on top of the stack, the int value of it without removing it, and then getMin is called again, and it's going to return -2. So there's a lot of different ways of implementing this. What I think of is a tree set when I see this getMin, because a tree set, when you add a object to a tree set, the data structure will return for you the minimum value with the convenience method that it has. So a tree set object keeps the objects ordered for you. There's first, that can that's for returning the min value in the stack. So something like top makes me think of an actual stack. A stack object gives you peak, and pop. Peak will show you the top value in the stack without removing it. And the stack object has another convenience method called pop, and this will remove the top of the stack, whatever is on it. So for this MinStack, let's create a tree set. I'm just going to call it TS, and it'll be a new tree set. So the problem, and then I'm going to make a new stack. So a new stack, and I'm just going to call it S, and it's a new stack. So this would be totally fine to use with an integer, but the problem is that a tree set will only hold unique objects. So what I'm going to do is just create my own custom object, and I'm going to have an ID and then the value in it. So they all can have unique IDs, and that will make them all unique objects. So let me make a custom object here, and I'll show you. So I'll say class, I'm just going to call it my custom object, just to show you that I'm really just using something super custom. And it's going to have the value, and that's going to hold the value that we're adding in the push, and then it's going to have an ID. So This will be custom object. This is the constructor for a my custom object. So whenever a new custom object is made, we're going to have a value for it, and we're going to have an ID for it. So it's going to say this ID equals ID. So this ID here is going to be the ID that's passed through. And I'm going to say this val is going to be equal to val. So that's it. I have my custom object here. I'm going to actually take this constructor. You can do this a couple of different styles. You can have these objects initialized within the constructor, but I'm just going to have them initialized outside the constructor because I have a bunch of things that I want to initialize. So when I make my tree set, I'm going to make it, the type of my custom object. And the stack is going to also be my custom object. I don't have to, I'm just going to do it like this. It's going to be 2. Okay. And I'm going to have this count right here that I'm going to set at 0. And I'm going to increase the count every single time I push something. And that's going to be the ID, so that I'm going to know that there's going to be a higher count every time. Okay. So I have my tree set, I have my stack, and I'm going to implement here this lambda function, so it's going to tell my tree set every time you add something. This is the logic that I want you to use to order the items. So I'm going to say when you get an item, it's going to be A or B. I can call this whatever I want. I can call it A, and B, B. Whenever you get one item and how to compare it to the other items, you're going to just say, look at that integer and then compare it to the A value and the B value. So that means when you're getting a my custom object, you want to compare the values there, and you want to order it by that value. So even though these items are outside, they're going to be initialized in my constructor. So let's do our push. So every time we do a push, we're going to make a new custom object. So I'm going to say my custom object, I'm just going to call it O, equals a new my custom object, and I'm going to pass through a value and then an ID. So it's going to be the value that's here, and then I'm going to take this count, and I'm just going to say it's whatever the count is, and I'm going to add one more to the count after I'm done. So it's going to be count plus plus, so it's making a new custom object. And I'm going to add it to the tree set, and then I'm going to also add it to the stack. Okay. So let's go to pop. So if we want to pop something, I'm just going to say test pop. But I'm also going to need to remove it from the tree set. So I'm going to use this function called remove if. So this is not quite so efficient, but it's good to know this method called remove if. So I'm going to say remove if, and then it's going to look through any item in the tree, every item in the tree set. I'm going to say like look through every one. And again, this is going to be a lambda function. I'm just naming this whatever I want it to be. And it says for every one of them, just see if that ID is equal to, let's see here, to the one that's spop. I'm going to say which one to pop. I'm just going to call this O. So it's going to be this object O. Today I'm just going to call it something different since you know it's different than here. Sorry, I messed that up in here. This is supposed to be count. It's supposed to be my custom object. So move if this object ID is equal to the obj ID. Because right now the stack and the tree set, they have the same objects. So I'm going to find the ID of the one that is popped. So I'm just going to take it, it's going to pop it off, and I'm going to say, like, go through every one in the tree set, and if the ID is equal to the one I just popped off, we're going to remove it from the tree set. So for top, we're just going to say maybe return, I'm just going to call peek on it, .val. There's different ways to do it. You can just return it like that. You can just say like int I is going to be s peek, like that, and then you can just return I, but I'm just going to put it all in one line. And there's nothing you have to do there because the tree set can keep the same items, and the stack is not going to be changed if you call peek on it. And now for getMin, this is going to be the part where we're going to be grateful that we use the tree set, because we just have to return whatever is in the tree set. Oh, dot tree set. I'm just going to call first on it, and then val. So this is going to take the first value in the tree set, because we ordered it by our values. And that should work. Let's see what else we have. Okay. I'm going to run it. Line 15. No, I shouldn't have that there. Oh, so I have A, and B, B. All right. What did I call this? I would call this TX. This is TS. Okay. You could also see if this could be A, B, B, A, B, B. It doesn't matter what you call these things. You just call this like comp, and this is going to be comp. We can just print this out here. You can see our first value is 3, and then it changed to -2. They don't give us other examples, but okay, so that should be that. That's a couple of things covered. Making a custom class and using tree set with the lambda function for a custom comparer or comparator, and using remove if as well as this tree set first dot value. So let's see if I can have all the code on one spot. I don't think so, but hopefully you can see it pretty well. put this all in one line too, so it's easier to read.